Hi guys, today I'm going to be showing you how to connect the BeagleBone Black to your computer and install C code that will control the GPIO pins on the BeagleBone Black. I'm going to show this for Windows 7, Windows 8, and Windows 10. I want to talk about the expansion headers on the BeagleBone Black. They are separated into headers P8 and P9, with P8 being on the right and P9 being on the left. The reason why they are separated into two is because each header has 46 pins on it. Now, if they left them as pins 1 through 92, it would be very confusing to say, oh, pin 86 is output. It's hard to tell, okay, let's find pin 86. So they just left it as pins 1 through 46 on header P8 and P9. So if you need to know which one is P8 and which one is P9, you can either memorize how I have in the picture here, or you can look on the board itself and they say P8 and P9 right at the back of them and in really small writing. So when you have a BeagleBone in your hand, you'll be able to see that. Any boxes in red is all the stuff that has to do with power. Okay, so all these red rectangles here are all power related. VDD 3V3 and VDD 5V are both voltage sources. 3V3 is a 3.3 voltage source and the 5V is a 5 voltage source. So depending on your application, you can use either one of the voltage pins. The DG and D is a ground pin. So all of your ground connections will go to those ground pins. It's pretty self-explanatory. 5V, 5 volts, 3V3, 3.3 volts, G and D, ground. However, the green rectangles with the thick black border around them are all GPIO pins. These are all pins that we will be interfacing with. They can be set to a logic level high, which is 3.3 volts, or a logic level low, 0 volts. You can create a clock signal with them, you could turn LEDs on or off, or you can measure inputs with push buttons or switches. These are the only pins that can be changed. We cannot manipulate the red ones, and we cannot manipulate any of the other pins on the BeagleBone. I know that there are 92 pins on there. However, I've went through and checked every single pin myself, and these are the only pins that work with this specific library. So I will go over how to interface with them later, but for now we're going to demonstrate how to hook up your BeagleBone Black to your computer and get started with that. So without further ado, let's get started. So the first thing you're going to want to do is plug in your BeagleBone to your computer. Okay. If you plug it in, you should see the power button start up, and then you should see all 4 LEDs light up. If you do not, the BeagleBone is either broken or your laptop cannot supply enough power to power it on. At that point, you will need to get a 5-volt adapter and then power the BeagleBone with the 5-volt adapter, and then plug the BeagleBone into your computer. Now, the top light should be blinking in a heartbeat-like pattern. That is the BeagleBone's heartbeat. The second light from the top is showing activity on the micro SD card. Because we don't have one put in, this one should be blank. The third light from the top is the CPU activity light. So for the first, 3 minutes, it should be pretty solid on because the CPU is doing a lot of activity. And the bottom light, or the fourth light from the top, is the light that measures the flash memory activity. So those should all be blinking and doing their own thing. If they're not, something is wrong with your BeagleBone. And once it's plugged in, you are going to want to go to the File Explorer. So wherever that is, either Windows 8 or Windows 7, you're going to want to go there. Now scroll down to where you see BeagleBone Getting Started. This should be under this PC. Okay. So now you have all of these things. Double click on start.html. Sorry. Now, it wants us to install drivers. Okay, now this is important. If you have a 64-bit OS, you're going to want to install the 64-bit version. If you have a 32-bit OS, you're going to want to install the 32-bit version. If you don't know what version you have, just install the 64-bit one, and if it doesn't work, then we know that you have the 32-bit one. It's very simple. It'll tell you if it doesn't work. I have a 64-bit, so I'm going to download that one. We're going to save it to my desktop. You guys can save it wherever. It doesn't matter where you save it. Now we're going to run it. Next. Okay, now because I'm on Windows 8, all of these failed. Don't worry, this is normal. For Windows 7 users, it will run, however, it will say this driver is not digitally signed. So do you want to proceed with this anyways? Just go ahead and click proceed. I know it looks like a security risk, but I guarantee you it's not. It's just the fact that Windows is not happy with the fact that these drivers are not signed, so it's just making sure that you're okay with installing these. So go ahead and go ahead and install anyway. It'll pop up like 5 or 7 times. Just keep hitting install anyways. For us Windows 8 users, we are going to have to work around this a little bit. So you can just go ahead and click cancel. And what you're going to want to do now is restart your computer. Now the trick to this is when you go up to your restart menu or button, hold shift down and then click restart. Okay, this will launch you into the boot menu. And then from there, we're going to choose disabled driver verification signature. Okay, I'm going to restart my computer and then I will show you what to do from there. Now that your computer's restarted, it gives you a bunch of options to do. We're going to go to troubleshoot, advanced options, startup settings. Okay, now hit restart right here. Okay, so now it says startup settings. Use number keys or functions to choose which one we want to do. We want to choose number 7, disable driver signature enforcement. So just hit the 7 key and it'll restart. So now that our computer's restarted, we can go ahead and run the same files that we did earlier. Click next. Go ahead and click install this driver software anyway. And again, the reason why Windows is doing this is because these drivers are not digitally signed, so it thinks it is an attack against your computer. And it is not, because they are from the BeagleBone's website. However, we had to bypass this because it's a security feature built into Windows. So it's completely fine. Again, I assure you that nothing wrong is happening. So when it's done, it should all have green check marks over in that left over there, okay, and status should be ready to use. If it's not, I recommend going back and redoing this step because we need to have all of these in operation. So go ahead and click finish. Now before we continue, we're going to want to restart our computer without the shift click, just a regular restart, because we're still in the bypass for the disabled driver verification. And we don't want to do that just in case, you know, something bad happens. So restart your computer, and I'm going to restart mine, and then we will continue with the next part. Okay, so now we're ready to put code on the BeagleBone. For this, we're going to need to first write a piece of code. So let's do that. You can use any editor you want. I use Notepad. Okay, so first thing we do is hashtag include stdio.h, hashtag include stdlib.h, and hashtag include iolib.c, not .h. I know it's weird, but just trust me, this is how the code works. Alright, the next thing we need to do is write the main function. So int main void int led equals 12, int button equals 11. We're setting up the pin numbers right now. So the LED will equal 12 and the button will equal 11. Okay, so now we do iolib underscore init. What this does is it initializes the input-output library for the GPIO pins. It gets things set up, it gets everything ready so that you can access them. Then we need to do iolib underscore set direction 8, LED, dir underscore out. Okay, now what this does is it sets the pin header 8, that's what this 8 is, it sets header 8, pin 12, because LED equals 12, as an output. Okay, so again, header 8, pin 12 as an output. Alright, and then we're going to say iolib underscore set dir 8 header 8 pin 11 or button dir underscore in. So now this is saying that on header 8 pin 11 there is an input. So this will be the input and this will be the output, or this will be the LED and this will be the button. Pretty self-explanatory. Okay, so now after that we want to do something that will help us see that our code is running. We're going to do printf quote \n. Now we really don't need this. This isn't exactly necessary, but I do this so that I know that my code actually did work. Okay. Forgot my \n. It's not a semicolon. All right. So after we have that, we move on to the while loop. While 1 if is high header 8 pin 11 okay, then pin high header 8 pin 12, and then else, I'll go over what all of this means as soon as I'm done writing this, else pin low 8 LED. So what this says is, first of all, loop infinitely. If the input pin 11 is high, then make the output pin, pin 12, high as well. So, in other words, if the button is pressed, then turn on the LED. Else, if the button is not pressed, then turn off the LED. Okay? So that's all this does. If the button's pressed, turn it on. If it isn't, turn it off. And then after that, we do iolib underscore free. And all that does is it frees up all of the things that iolib underscore init did. So it's just kind of a cleanup. And then you close your main brackets. So if we didn't want this, if we wanted to invert this, so instead of if button pressed then LED on, we could say if button pressed LED off. All we would have to do is just change this to low. So if the button is not pressed, then the LED is on. But if the button is pressed, then the LED is off. Well, for our purposes, we're going to keep it as high. Okay? So now we can save it. We're going to save it to my desktop. I'm going to call it pin.c. You guys can call it whatever you'd like, but just make sure you remember that name. Okay? So save it. Here it is. Here's my pin.c. Okay? So now in order to get this over to the BeagleBone, we need to download a software called PSFTP. So we're going to type that in here. PSFTP. We're going to go to the PuTTY download page. And we're going to click this right here, PSFTP. I'm going to save it to my desktop. And double click. So at this point, you're going to want to plug in your BeagleBone. Make sure that your computer has recognized that it's in. If you don't see it listed here, wait for it to become listed, because if the computer doesn't see it, then this step right here will not work. So wait for that to happen. Okay, so now what you're going to want to do is type open and then space 192.168.7.2. That is the IP address to the BeagleBone. Now, some of you guys might have just gotten a message saying security breach. All that's saying is that numbers don't match up, because when you SSH into a device, a computer has a fingerprint of what it thinks is it's accessing. However, because your computer has never seen this BeagleBone before, the so-called fingerprint it has doesn't match up. So it's just saying, hey, I'm thinking this, but really I'm getting this. This is wrong. This could be bad. It's not bad. I promise you it's okay. So just go ahead and click yes or cancel or whatever. And then once you get there, it'll say login as. Now you type root. Okay, so now you're going to do cd, enter, cd dot dot, cd slash home, or not slash home, sorry, cd home slash debian slash desktop. Now it says remote directory is now home debian desktop. Now we're going to use a command called mput, and then the directory to where your pin.c is. Okay, so now we have to say that directory. So quote, make sure it's in quotes, otherwise this will not work. I know my directory to where pin C is C:/ users / John / desktop / pin.c, end quote. Okay, then hit enter. So now from the local machine, C users John desktop pin.c has been transferred to remote directory / home / debian / desktop. So now if we type in ls, this says the listing directory / home / debian / desktop, we see pin.c. So our program has made it over to the BeagleBone. Okay, so at this point we can't do anything more further. We have to download a second program. So you can go ahead and type exit, and that will shut down PSFTP. And now from this same exact page here, you're going to want to download PuTTY. Okay, so again, save that to your desktop. It's called putty.exe, and then open PuTTY. Now, PuTTY does the same thing as PSFTP. The only difference between them two is that PuTTY cannot exchange files. It's only SSH. You can only SSH into a device. PSFTP allows you to transfer files over. So for the host name or IP address, we're going to type 192.168.7.2. Okay, because that's the address of the BeagleBone. Leave the port as 22. Make sure SSH is enabled. Okay, and then we're going to name this BBB_SSH. You can name it whatever you want. The only reason I'm naming it this is because I know that this is the SSH into the BeagleBone. Okay, so I just save it, and then when I want to load this, I just double click it, and then it loads. So the login as root, sorry, login as root. Now we do cd, enter, cd dot dot, cd / home / debian / desktop, ls-al, and as we can see, our pin.c is still there. So now that we're on the BeagleBone and we have our code on the BeagleBone, we will type the compile command, because we can't just run this C file. We have to compile it first, because the computer can't understand just the C code. So we type gcc space pin.c -lio func -o main. Now what this does is, this is saying, okay, we're going to compile the file pin.c with the library lio func and output the file and call it main. Okay, now you can change this main to test, you can change it to test2, you can change it to example, you can change it to whatever you would like. The only reason I say main is because it's nice and simple. So once you hit compile, okay, so compiled with no errors, and then to run it we do /main. And as we can see, it said worked, so we know our code works. So now let's take a look at the hardware portion of it and see what's going on there. Okay, so the setup of this is as follows. We have our VDD 3v3 on pin 2 on the P9 header coming out, going into the power rail. Power rail comes down through the 10K resistor into the button and then out the button through the white wire, which goes into pin 11, which is on the P8 header. Okay, then that is our input. Our output on pin 12, which is the red wire, comes out, goes through the 1K resistor, and then into the LED, out, and then through the ground rail, and then through the ground wire, into pin 2 on the P8 header. Okay, the headers also have labels. There's the label here that says pin 8, and the label here that says pin 9. These are on the back of the BeagleBone. So, given this circuit, and assuming that your code is up and running, if we press the button, the LED turns on, just as expected. When the button is pressed down, the LED is on. When I let go of the button, the LED is off. So using those 4 functions I went over, you can essentially create anything you would like.